A warm evening, everyone. It is my great pleasure to welcome you all back to another episode of our Tech Talk series, proudly organized by the Software Engineering Students Association of University of Kelaniya. Today, we are going to dive into a really insightful session, bridging the gap and preparing for AI, ML, and data science internships. As software engineering students, we are well prepared for building robust systems, managing life cycles, and writing clean code. However, when we look to forward AI and machine learning, it is often a significant gap between traditional software engineering practices and the data-centric mindset required for AI internships. This session is especially designed to bridge that gap and helping you to understand how to pivot your software engineering fundamentals into a successful career in data science and machine learning. To guide us through this valuable session, we have a very special guest, Mr. Warunajith Bandara, a software engineer specializing in AI and ML at Eutech Cybernetics. And also, I'm really proud to say he is one of our alumni of software engineering students as alumni of software engineering degree program in University of Kelaniya. So, without further delay, let's officially begin the session. I would like to invite Mr. Warunajith Bandara to continue the session. Over to you, sir.
Yeah, thank you, Daniel. Hopefully, I'm audible clearly.
Yes, you are audible.
Great, great, great. Give me 1 second to share the screen. All right. Can you see my screen?
Yes, the screen is visible.
Oh, okay, cool. Great. So, good evening, everyone. First of all, thank you very much, Software Engineering Students Association of University of Kelaniya for this invitation. So this is my second TechZeed session, and being back means a lot to me. So genuinely, thank you for trusting me with this another one. So let's get started with today's session. So we are going to discuss about data science, machine learning engineering, and AI engineering. This is kind of a beginner's guide to the most demand fields in today's world. Okay, let's get started. This is our agenda for today's session. This is a quick map of where we are going. We will open up with why these fields actually matters now, and then we will zoom out to see how the three fields, AI, ML, and data science, fit together as a one ecosystem. Then after that, we go deep into each domain, data science, ML, and AI, and then we will cover some concepts related to the these three fields by discussing about the common things and splitting apart things and kind of comparison between three domains. And finally, I will guide you how to get started with these pathways. Okay, let's start. So first, why this matters now? I think you can see a few numbers here. In today's world, data is created every day, every second. So in one particular day, it is assumed that 402 million terabytes of data generated, and global AI market really sorry guys, I think my connection dropped. Let me reshare the screen. Okay, am I audible, and is this my screen visible to you?
Yes, sir. Your screen is visible.
Okay, okay, cool. Okay, so really sorry for the delay. Okay, I will repeat the slide again. I don't remember where I lost my connection. However, by 2030, the global AI market is projected to hit $1.8 trillion. That's bigger than the GDP of most countries on the earth. And new jobs in AI domain will be created by 2030. The number of jobs would be around 170 million, and 82% of jobs, most of the executives predict that AI would be a most prioritized thing in upcoming few years. Okay, so what this means for you? So these are just the numbers. So what this means for you? Basically, data is everywhere, but the insight is rare. So almost every company on this earth is sitting on a gold mine of data that they don't know how to use those data. Millions of data generating day by day, but most of the companies do not use those data to useful activities. So the people who can extract the meaning from that data are in a critical demand. So, and that demand is growing faster than universities can produce the graduates. Next, AI is moving from research to reality now. So 5 years ago, the large language models were curiosity in research papers, but today they are shipping production level applications in every major companies. And third one is the entry point has never been lower. The entry point has actually with free tools, free and open source models like any tool that you can accessible via the internet, and cloud computing aspect also. So a beginner today can build things that required a PhD teams 5 years ago. So because of that, anyone can access these free tools and doing something impactful to the society. So this is why it matters. So let's move into the next slide. Okay, so I will skimming through this slide. This is how the field started and evolved throughout the past decades. Basically, in 1960 to 1980 decade, data science was actually started with statistical roots, and ML engineering is early AI and backpropagation algorithm or the concepts were introduced, but AI engineering part is not yet born in that decade. In 1990s to 2007, data science was dealing with business analytics, like using tools like Excel and SQL and any other business intelligence tools. So the business analyst was the closest role in that decade. And when it comes to the ML engineering, IBM Deep Blue beats the Kasparov 1997, and some support vector machines and distant tree mainstreams comes in, and ML is still a research in the bigger companies. And when it comes to AI engineering, it was kind of a web and search era, right? No LLMs developed at that decade also. So from 2008 to 2014, the real data science is born. Data scientist term is coined at LinkedIn and Facebook, and Kaggle launches in 2010. I will talk about the Kaggle in later slides. And in ML engineering perspective, deep learning takes over. So the AlexNet means the ImageNet 2012, and GPUs, with the introduction of GPUs, everything changed. And when the AI engineering, cloud ML APIs were started to introduce, and Google Prediction API launches, and ML as a service, Word2X, and text embeddings was also introduced in that decade. So 2015 to 2021, actually not the decade, this kind of 5 years period. So the notebooks and Power BI. In data science, Jupyter notebooks became the standard for the experimental things. Power BI and Tableau, like business intelligent tools, grow rapidly in enterprise level. And ML engineering perspective, ML ops term, machine learning operations, were coined, and also the TensorFlow, PyTorch, like deep learning libraries were introduced. MLflow, Airflow kind of libraries also introduced. And this is the time period the AI engineering was about to boost with the GPT-3. From 2022 to 2025, LLM enhances the data science. Gen AI, you already know about that. Gen AI adds text and image analysis to toolkits. LLM used for EDS, exploratory data analysis and report generation. So in ML engineering side, fine tuning, right, quantization become core ML skills. And also the AI engineering, it is a AI, actually the AI engineering was born in this with the introduction of ChatGPT in 2022. So this is the basic high level introduction to how this field is started and evolved. Keep in mind that these three disciplines share in the same DNA, like statistics, computation and data. And data science emerged in 2008, and ML engineering crystallized 2015, and AI engineering was born November 2022 with the introduction of ChatGPT as a chat application. Okay, moving forward with the presentation. Okay, this is the big picture of all these three domains basically. So this diagram clears up a confusion I see all the time. So basically, the artificial intelligence is the biggest box, and AI is any system that mimics human intelligence. And inside that AI, we have machine learning. ML is a specific approach to AI. ML system is also learns patterns from data rather than being explicitly programmed with rules, conditions, right? So modern AI is ML now, and inside machine learning we have deep learning. It is kind of specific machine learning that uses neural networks with many layers. So that's literally where the word deep comes from, and it is the engine behind the almost every breakthrough you have heard about in last few years. And inside deep learning we have generative AI models, generative AI models that creates new contents, and large language models you may heard about GPT and Claude, DALI and Sora. Almost all these models are generative models. Some of them generate text, some of them generate images, videos. Any formats of data can be generated using generative models. It is not limited just to text models, right? So now look to the site, the data science section. It overlaps with all of these, but it is not fully contained inside AI, right? So because the data science is mostly about insight and communication, it extracting meaning from the data using statistics or exploratory analysis and visualizations. A lot of data science doesn't involve AI at all, but SQL query that finds the top 10 products by revenue in data science. Bar chart in Tableau is a data science. The overlap with ML is a real. Data scientists do build predictive models using the machine learning concepts, but data science as a field is a broader one, right? So hold this picture in your mind. So this is the very high level representation of all these three fields. So I'm moving forward to next slide. Let's discuss about these three fields as a one ecosystem. So basically data science is a discovery layer. There's a central question: what does the data tell us? That is the main question in data science. So the statistics, exploratory analysis, visualizations, and prototype models, business storytelling, these are the output of the data science stream. So in ML engineering, it is a delivery layer. The major question in machine learning engineering is how do we make it reliable, which means we have MLOps pipeline, right, model deployments, then we have monitoring and retraining, and scaling and reliability of data and the models, right? So the final output of ML engineering is a working system. And when it comes to the AI engineering, it's an application layer. So the major question that the AI engineering is solving is that how do we build AI? how do we build with AI? Not AI. How do we build with AI? Basically, it has prompt engineering, RAG systems, AI agents, and building the product utilizing the existing uh, generative models or any AI model. These are the main questions that we ask in each domain, and each domain is answering that question using different kind of techniques. Alright, I'm moving forward, and here is how the handoff actually works in practice. So basically the data scientist takes in a raw data and a business question, and they hand off a validated model, usually in a notebook format, plus the evaluation matrices and domain knowledge they have already built up. So the ML engineer takes that prototype and hand off a live model endpoint and inference API or a monitoring dashboard to the AI engineer. The final output is a reliable infrastructure. Then the AI engineer takes that particular endpoint provided by the machine learning engineer, or it takes LLM APIs and builds something users can actually interact with. Maybe a chatbot or search experience or any chat agent, any kind of thing. So underneath all of it, a shared foundation is Python, SQL, basic machine learning concepts, cloud deployments, and all of these are shared in these three roles. Okay, next I'm going to discuss each and every domain one by one. So where the data science came from, it was born 2008 to 2014, and I discussed this thing in the previous slide. So basically it is the intersection of three things: statistics and inference, and computer science, and big data and cloud. So these three domains are intersected, and data science is born using these three things. So in data science also we have a life cycle. Basically it has collective stage, cleaning, exploring, modeling, and communicating. So in collective stage you pull the data from somewhere. It may be SQL queries or API calls, sometimes web scraping, right? So the data scientist is a person who knows where this every piece of data in the company lives. So the second one is cleaning. Data scientists spend roughly around 60 to 80% of their time on cleaning the data. Activities from the data cleaning is like handling missing values, duplicate records, inconsistent formats of the data, and typos of the data sets, and also outliers, right? So basically pandas is a particular library that we are using to handle these kind of data. So third we have EDA, exploratory data analysis. So we visualize all these data, we create charts, right? Compute summary statistics and look at the distribution of each data, and trying to develop an intuition about the data before we build anything using the existing data. So and next we have modeling. Modeling can be a statistical model or a machine learning model. So we have several libraries to modeling, like scikit-learn, basically for machine learning, and finally we have communication step. So the communication is this is where the most beginners underestimate the role. So you write a report, you build a dashboard using the existing data by analyzing the data, and finally you stand up in front of a marketing team and explain in plain English so what the data says actually and what they should do. So if they can't tell the story, the work doesn't matter. So this is how the data science life cycle is going, and at the end of this life cycle, data scientists create the notebooks and hand off to the machine learning engineer. That is how this is ended up. So basically we are using key tools like Python as a language, sometimes R, pandas and NumPy for data manipulation. SQL is also using, because most of the data is stored in relational databases, so SQL is a mandatory one, and Matplotlib and Seaborn libraries are utilizing for visualizing the data, like pie charts, right? Look at the distributions. So finally we have scikit-learn. It is a standard machine learning library, and Tableau and Power BI. These are the business intelligent tools. So we can create dashboards or reports using Power BI or Tableau. Right. So this is the introduction to the data science. So let's discuss about what a data scientist actually does. So the primary question is, what is the data telling us? Can we predict what will happen? This is the questions actually data scientists ask. So then the key outputs of data scientists would be reports and dashboards. It is the reports and dashboards are the major outputs. In addition to that, data scientists are capable of prototyping machine learning models and giving statistical insights as well. So the final audience of the data scientists would be the business stakeholders, product managers, or the executives, right? So it is ended up with a validated notebook, or the model is, or the developed model. So the final model needs to go to the production. So the machine learning engineers would take the model and continue from that part. So keep in mind that the data scientist is a part statistician, part analyst, part communicator, and the emphasis is on finding truth and explaining it, not deploying the code, right? So this is a major role of the data scientist theoretically. I will discuss the combination of the roles in later slides. Up to now, this is the entire role of the data scientist. Okay, next I'm going to discuss about the ML engineering. So ML engineering actually turning experiments into systems. So let me start with the problem ML engineering was born to solve. Imagine you are a data scientist and you spend 3 months building a kind of a fraud detection model, and it works beautifully on your laptop. So because data scientists exploring data and building models and hand off that models to machine learning engineer for the shipping. So 2 weeks later, the engineers come back to the data scientists by saying the model is too slow, it takes 4 seconds per prediction, and credit card teams need 100 milliseconds. Sometimes it crashes, and sometimes it works perfectly on Mondays, but its accuracy drops, right? So 30%. So that sometimes accuracy drops by this kind of percent by Friday. Data distribution shifted, nobody noticed. So, and every time the data team updates the schema, the whole thing breaks, right? These kind of things happening in the production environment. So the this gap between works on laptop and works on millions of users for 24/7 for years is what ML engineering exists to close. So it is a difference between a science experiment and the industrial system. Basically, data scientists exploring the things, finally building a model and hand over to the machine learning team to deploy, but it doesn't work as expected in the production environment. So as a solution, the ML ops pipeline has come to the picture. It covers the 5 core stages and ML engineer owns or contributes to all of them. So first we have data pipeline. In machine learning engineering, we have data pipelines. We are using tools like Airflow, Spark, and doing ETLs. So extract, transform, and load. So basically, the raw data comes from hundreds of sources. It needs to be cleaned, validated, and stored in a feature store, and so that the model can be used. This is engineering. This is not analysis. So basically, data pipeline takes the data and do the necessary manipulation and store in particular place so that the model can use it. Then the model training pipeline. So data scientists might have trained the model on laptop, but the production version trained on GPU clusters sometimes. Right? So the experiment tracking through tools like MLflow. While training, we have to track the models. Models can have different versions based on the accuracies. Right. So next we have model serving stage. This is a stage where the model is wrapped with the API. So at the end of the day, we have to produce an API so that it can be utilized by the users to get their works done. So basically, we use fast API kind of web frameworks to serve in the model. And also, we are not limited to that stage. We have monitoring after the deployment. So while monitoring, we can detect data drifts, right? We can get the alerts regarding the running models, right? So finally, we have a retraining stage as well. So over the time, data can be shifted. Data might be changed, data drift, the distribution can be changed. So models need to be retrained again and again. Right? This is the entire ML machine learning pipeline. I would say machine learning life cycle also. So these are the main things that the ML engineer does. So if we talk about what an ML engineer cares about is basically the latency, uptime, data drift, and reliability. So these are the major things that we should consider when we are doing ML engineering, rather than just visualizing the data or training and building a model. There are a lot more to do in machine learning engineering. Right, so I will move forward with the next slide. So next we have AI engineering. Before talking about the AI engineering, we need to discuss about the deep learning, because the deep learning is the engine behind the almost everything you have heard about AI in today's world. It is the bridge that connects the ML engineering to AI engineering. So basically we have 3 core architectures in deep learning: convolutional neural networks, which is basically utilizing for training for images and computer vision. Face recognition and object detection is also a part of CNNs, convolutional neural networks. Then we have recurrent neural networks and LSTMs, basically dealing with sequential data or time series data, like speech, text, sensor data. Right? So those are the data that we are dealing with in LSTM. And transformers. Transformers are the language and multimodals, attention-based architecture. This is the backbone of the all modern LLMs. So the key tools that we are using in deep learning is that PyTorch and TensorFlow Keras deep learning libraries, Hugging Face, right? So the CUDA. CUDA is kind of the library to library provided by NVIDIA to run the models in GPUs, and the Google Colab. Google Colab is a platform provided by Google to run your models or train your models in their GPUs. It is free tool. So the bridge between these two is that transformers. So the LLM just are just very deep learning transform models. So understanding deep learnings gives you an intuition for what AI APIs are doing under the hood. So with the introduction of transformers in 2017 paper, there was a research paper out from the Google. The title was, as I remember, attention is all you need. So with that research paper, everything was about started to change. So as a result of that, GPT was introduced, ChatGPT, right? Along with following that, so many generative models were developed within last 5 years. So this is the bridge from going to machine learning engineering to the AI engineering. Next, I'm going to discuss about the AI engineering. Basically, the AI engineering, it has 3 pillars: prompt engineering, RAG systems, and AI agents. So when it comes to prompt engineering, when the LLMs were introduced, so people were chatting with LLM or asking a single question and get back the answer from the model. But in order to use these LLMs efficiently, so we should have a proper inputs, right? So in order to get the output, the reliable output from the LLM, we should design proper prompts. So we have some prompting techniques like zero-shot prompting, few-shot prompting, chain of thought, tree of thought, right? So if you are using that kind of prompting techniques, we can get reliable and high quality outputs from LLMs. So, and also it gives, we can define the output type or the output format, so that we can get the structured outputs from the LLMs. Next, we have RAG systems. So the term RAG is known as retrieval augmented generation. It giving the LLM access to your documents through vector database and embeddings. So if I talk about these RAG systems, so when a user asks a question, first it retrieves the relevant documents from our private knowledge base. So the purpose of introducing this RAG system to the industry was that, so the LLM, the large language model, has the limited knowledge, which means it was trained with historical data up to certain time, right? So it doesn't know the updated data regarding the war data, right? The recently war data, Iran and right? Israel and the recent updates about the world economics and anything. So the LLM doesn't know about those latest update after it was trained. So we need separate database to fetch those data. So in order to solve this question, the RAG was introduced. So in here we have our private database for the data sources. We get that data source and store this data as a document, which means we says vectors. So we convert these our documents into vectors and store in a particular vector database. Then when user asks a question, you first retrieve the relevant documents from that private vector database, which is our private knowledge base, and along with that context we provide the question, and model will generate the output based on the question and the provided context, which means the retrieved content from our private knowledge base. In that case, the answer would be a updated one because it has up-to-date data. So we have different tools and frameworks to implement these kind of systems. So we have Pinecone like vector databases, LangChain like libraries for developing RAG systems, right? So next we have AI agents. In AI, AI agent is actually a system. It doesn't just answering the question, and it has the ability to take the actions, right? So it can search the web, it can run the code, call multiple APIs, read files, write files, right? So chain multiple steps and complete a particular goal, right? It has different toolkits to do the multiple actions. We can have a single agent, or we can build multi-agent systems for completing multiple tasks. So the most important thing in AI agent is a tool call. So it is actually a function. So we give the agent to access to these tools, and it can utilize the tools as needed when a particular user asks a question. So as an example, you can create an agent to for example, we can create agentic system for trip planning, right? So we can create one agent for booking hotels and another agent for planning the or booking the air tickets and planning the trip in the local areas. So we can have multiple agents, and we can get done our entire trip. We can plan our entire trip using a particular multi-agentic system. So in addition to that, in today's world, we have a new concept called Model Context Protocol, which was introduced by Anthropic in 2024, which is becoming a standard for how models talk to tools and data sources. So you may not familiar with this much more. And also memory systems, right? So early days we didn't have memory for the agents, so now the memory systems also developing two agents in order to keep the historical chats between the users for each session, right? So this is all about the AI engineering. So what makes AI engineering distinct is, here we don't train the models, so we just utilizing the existing models, right? So this is the newest field born 2022 after introduction of ChatGPT, right? So now let's discuss about how these three fields intersects, overlap and deviate each other. Basically, data science and machine learning engineering shared multiple things: model training kind of thing, feature engineering, and experiment tracking. Right. So, scikit-learn library, evaluation metrics, those are shared by data scientists and machine learning engineering. When it comes to the machine learning and AI engineering, basically fine-tuning LLMs and deploying embedding models, right, are shared. Fine-tuning LLM is that in AI engineering we are using the existing large language models provided by OpenAI or Claude. But if we want to use that LLM or specialize that particular large language model for particular domain, let's say a healthcare domain, so in that case we have to have our private data set and teach that existing large language model to model about our data, which means the healthcare domain. Basically LLM has a generalized knowledge but doesn't have specific knowledge in a special field. So in that case we are doing fine tuning kind of thing, make that LLM more specialized about the particular domain. So it is a shared one. The machine learning engineer can do this fine tuning things. So next, data science and AI engineering overlapping. So basically large language models are now utilizing for evaluating the utilizing for data pre-processing. So we can use LLMs for some particular data pre-processing aspects in data science. These are the overlapping zones in each fields, and also it has some uniquely owned things as well. In data science, statistical inference is unique to data science. Business storytelling, casual reasoning, those are unique to that particular field. And ML engineering owns Docker deployment, distributed training, right? So low latency serving and data drift detection and automate, right? So the AI engineering also uniquely owns prompt engineering. So it doesn't use in any field. It is using only in AI with large language models, RAG pipelines, agentic architectures, and large language models evaluation frameworks. So I want to emphasize one thing here. In startup companies, one person often wear all three hats. That's right. So in large companies, each domain, it has a distinct department and different roles. So honestly, in Sri Lanka, if we hire a data scientist for a particular company, data scientist doesn't the data scientist is not limited to only that previously discussed activities. Of course, data scientists should have experience in machine learning kind of things, model training pipeline, deploying, right, retraining, monitoring, everything should be included to data scientist role, and also machine learning engineering as well, right? So in AI engineering also, if a particular company hires an AI engineer, that person should have the ability to train the models, right, deploying the models, and also utilizing the large language models with trending technologies like agentic systems, RAG systems, right? So it's your decision. You can select particular role and it's good to have knowledge in other fields as well. Alright, so next I'm going to discuss the questions that separates them. Basically, before discussing the starting point of the, before getting started with the internship readiness, ask these questions to separate these three roles. So data scientist, basically data scientist asking the question, what is the data telling us, and can we predict what will happen in the future? That's the main question in data science history. In embedded engineering, asking a question, how do we serve this particular model to millions of users at less than 200 millisecond latency and know when it degrades? In AI engineering, ask this question, how do I wire this large language model into a product that users will actually find useful and trust? These are the major questions that these domains going to solve. Right? This is the question that separates all these three fields. Okay, this is the point I wanted to deeply going through. Getting it started. Let's get started with discussing the learning path of all these three. So this is the artwork function. No matter which role you target, these are non-negotiable. Everyone starts here. First one is Python. Right? Python is a mandatory one. Right? This is the universal language of all three fields. You have to know the variables, loops, functions, double OP. Right? You don't need to be an expert in Python, but you need to be able to write a 100-line script without stopping every 5 minutes. Right? So next, and also I think Python is not hard, right? So because almost all of you have learned about the programming in your first year in C programming language, I guess, and in first year second semester I think you may have learned Java. So learning Python is not a big deal. It's very friendly language to English, so you can quickly shift from one particular language to Python. Right? No complex syntaxes here. Okay, so learn Python and then learn about the SQL. This is I think no need of talking more about SQL. Everyone knows about SQL because your regular program has SQL. You may have all of you are taught SQL in your I think the second semester, right? First year second semester. So just learn about the SQL syntaxes, selects, where conditions, joins, group by, right? So we need to deal with the SQL databases in any field, data science, machine learning. We have to deal with the data, right? So third one is Git and GitHub. Learn about Git, how to commit, how to push, how to pull, right? Merging, resolving the conflicts, and carefully you have to maintain your GitHub profile with different projects. So your GitHub profile is a portfolio in future. Recruiters will look at your GitHub and you should maintain it properly, right? So start populating your GitHub from what you learn, right? Fourth one is math basics like linear algebra, vectors, matrices, and calculus, with derivatives, right? We need calculus to understand the backpropagation algorithm in deep learning, at least conceptually, right? So not only that, the probability and statistics is most important thing. We need to understand the distributions, mean, variance, hypothesis testing, right? So learn these things. I think the mathematics in first year you have two PMAT subjects. I guess when I was there, there was two modules in first year, first semester and second semester. It was covering all of these matrices kind of thing. And second year we had another PMAT subject. It covered calculus and derivative kind of modules. So I didn't want to learn mathematics in outside knowledge sources, right? So entire degree program covered almost all the mathematics basics that was required for the machine learning and deep learning, and statistics as well. You have a statistics separate module in your first year, so that's enough for getting started with machine learning, right? So next you should learn NumPy and Pandas. NumPy and Pandas are standard Python libraries dedicated for data manipulation. So master these libraries, right? So most of the beginners try to skip this thing and go ahead with scikit-learn library for model building kind of thing, but spend few days, few weeks by learning how to handle the data, with NumPy and Pandas, right? Next, you have to learn about the core machine learning concepts, like what is supervised machine learning, what is unsupervised learning, right? So model overfitting, train test splits, right? And accuracy, precision, recall, like performance matrices. So you need to know what the words means and when to each one applies in machine learning. So these are the basics that you cannot avoid, right? So start learning these things. So as a starter project, you can search the Titanic survival prediction on Kaggle. Kaggle is a website, and do exploratory data analysis and apply logistic regression modeling, and finally you can push that code into GitHub. So the Kaggle is a website. Let me share this screen. Let me show you the Kaggle website now. Kaggle.com.
Thank you, Mr. Warunajith, for that incredibly insightful session. Hope you have.
This is.
Oh no.
Oh, sorry. I just sharing this.
Sorry.
Okay. No worries. I just sharing the Kaggle website so that you can see what it is. And this is Kaggle website. This website you can see multiple data sets, right? So you can download the data here. You can search for the data set by refreshing this website. Okay, let me share the screen back to the presentation. Okay, next we have phase 2. So phase 2, pick your path and go deep. Phase 2 if you are dive deep in data science, you should study data cleaning techniques, outlier detection, feature engineering and encoding, classification and regression models, clustering techniques like K-means and principal component analysis, model evaluation using accuracy, F1 score, R2 score kind of thing, and learn how to visualize the dashboards using the existing data sets. Right, so in there you have to use pandas, numpy and scikit-learn, Power BI and Tableau kind of tools. In machine learning, so you have to practice and study the data ingestion. What is data ingestion? What is model training? Inferencing, and learn how to develop these pipelines, and then learn about the deep learning, like how the convolutional neural networks are built, RNNs, how the transformers are working. Right? Learn about the architectures of these models. Right? So next you can serving the models with Fast API and learn about Fast API. It is Fast API is a Python web framework like Django and Flask. Fast API is mostly using in production level, and learn about how to deploy a particular application into cloud, right, using Docker or CI/CD pipelines, and then finally learn how to monitoring and retraining the models. So you have to learn about TensorFlow, MLflow like libraries, and how to containerization using Docker. Right? So next next you have to learn AI engineering, starting by prompt engineering. Then you can learn about rack systems, what is embedding, what are the vector databases, why it is happening, use LLMs to classification using zero shot prompting, and what is AI agent, what is tool calling, right? Deploy the developed AI applications with Fast API to production, right? These are the this is how you should learn, but keep in mind that pick one track and go deep in one particular. You cannot learn everything at once, right? My advice is starting learning from the data science side, right? Basically you will cover almost all the things regarding to data in data science section, then come to machine learning, which means bringing the trained model to a production level, right? So in machine learning engineering you will apply kind of production level coding, right? Double OP principles, right? Clean coding and containerization, right? So the production level practices would be mostly used in ML engineering and also in AI engineering, right? So first one is data science, then come to the machine learning, and finally come to the AI engineering. That is the flow. Next, phase 3, build the projects that prove your skills. Basically the tutorials give you a vocabulary, projects give you understanding. So flip the ratio, 20% tutorials and 80% building the projects by yourself. So I would suggest 2 projects for data science. First one is picking a particular data set in Kaggle and do the EDA, exploratory data analysis, like by cleaning, exploring, finally training models and comparing models, right? Finally developing dashboards using Power BI, right? It is one project. The second one is kind of machine learning project, customer churn prediction, or any or like house price prediction kind of project you can pick. Basically, you can do the feature engineering, right? Handling imbalances, right? Training the model with XGBoost, applying hyperparameter tuning with grid search CV, right? So these two projects would be more helpful in data science because it will cover almost all the tools and techniques you need to know as a data scientist, right? So this is just a suggestion. You can pick any dataset or any project that you prefer. So when it comes to ML engineering, try to train a model and deploy it, right? In data science part, you have developed the models, but you haven't deployed it. So next step is to bring the model to production or the server, right? So wrap the model with fast API and containerize it with Docker and deploy to Hugging Face. Hugging Face, I will discuss about the Hugging Face or the AWS servers, EC2, right? EC2 servers. And Hugging Face is I will discuss Hugging Face in the final slide. There's a separate section for that. And second one is a deep learning projects. So the first project is deploying a machine learning model, and second one is learning about the deep learning. Deep learning means learn about the CNNs, convolutional neural networks. So dealing with image dataset by image classification project like cat and dog classification, and LSTM project using time series data like stock price prediction, sensor data prediction, right? That kind of projects. Right? Those projects would highlight to deep learning knowledge as well. And when it comes to AI engineering, you can build RAG chatbots and AI agent. So while developing RAG chatbots, you will learn about the basic concepts like chunking, embedding, right, utilizing vector databases, LLM APIs like OpenAI and Anthropic. And when it comes to agentic AI, you can develop multi-agent systems, right, which utilizing different tools, right? So these are the two projects that I am suggesting you to when you are getting started with the AI engineering. So when you push the codes, make clear README file in every project, right? If you can deploy it to a particular server, you can ideally put the link of the live demo of that project, right? So these are the projects that I am suggesting you. So next I would like to discuss about top resources and certification to get started. So as certifications, I recommend machine learning specialization course provided by Coursera as a collaboration with the collaboration of deeplearning.ai and the deep learning specialization as well, both provided by deeplearning.ai and available in Coursera. And those two courses have financial aids in Coursera. You may have to bear 10% of total course certificate price, right? And we have generative AI with LLMs. It's also provided by deeplearning.ai. And finally, I would recommend AWS Cloud Technical Essentials in order to get started with cloud. So in each and every role, you should know how to deal with the cloud, right? Every job you are applying, they are expecting your cloud skills, right? So I recommend these 4 courses, certifications to follow. Then if I talk about the YouTube channels, there's a YouTube channel called Krishnaik. It is covering all the tracks: data science, deep learning, machine learning, AI engineering. Everything covers in that channel. And AI with Takshila. It has two channels, like English and Sinhala versions, specifically for Sri Lankan learners. Because the Sinhala language is also available there. And DS with Bappi is specifically focused on MLOps, deep learning kind of thing. These are the YouTube channels. And paid courses. Sukru is one of the trending course in Sri Lanka. I'm also following some of the courses in that website. It has production level machine learning and AI courses covering real world deployments. And Euron is an Indian one. It is a little bit, the cost is a little bit higher, but the Sukru doesn't cost much, right? So these are the YouTube channels and paid courses. I will show you the links and website after discussing this. And as other sources, in order to practice, you can use Kaggle. Kaggle website I showed you. It has competitions, notebooks, and free GPUs. You can run the notebooks there as well. And for reading articles, you can learn, search through the Towards Data Science Medium channel. Right? I think you know about the Medium. Towards Data Science is publishing good articles related to data science, AI, and ML. And platforms like Hugging Face. Right? So Hugging Face is something, in software engineering we have GitHub as a central repository system. Hugging Face is also like GitHub, which provide users to upload their models, datasets, and providing space. Right? So anyone can clone that model to their local, clone the datasets, and utilize those data. Right? So Google Colab, it is a free GPU for deep learning model training and deep related developments provided by Google. I will show you the Google Colab as well. So let me share this screen. Let me show you actually the website. So this is Coursera, the machine learning specialization course. Right? You can apply financial aids. I'm not sure it is available here. First you have to apply, register the course. And deep learning as well. Third one is generative AI with large language models. Finally, AWS Cloud Essentials. YouTube channels. Krishnaik, this is the channel. Right? This has lots of videos to highly updating YouTube channel. Right? You can refer this. It has multiple playlists. You can learn everything here. Right? Agents, right? MCP. Right? It is a little bit advanced. You can learn Python as well. Right? I can find the playlist. So many playlists here. You can search through this channel. And next, AI with Takshila. This is one of my tutor. I was started learning AI with him. He has two channels. This is single one, and additionally he has a English channel as well. Right? You can start learning Python here as well. Yeah, Python full course, Python basics and Python modules like NumPy, Matplotlib, Pandas, right, and advanced Python. And finally you have DS with Bappi. It also contains multiple videos related to data science, deep learning, and machine learning. This is for Power BI analytics, right, agentic AI, right? So AWS deployment things as well. And we have Sukru. This is Sri Lankan one. Lectures are conducted by industry expert. I highly recommend this website. You can join with them, Sukru. They have provided foundational machine learning and production ready machine learning, AI engineering, and these days they are providing data warehouse kind of things. This kind of data engineering courses. Highly recommend this website. Next we have Euron. This is Indian education platform. The subscription is a little bit high, so I'm not highly recommend this one, but because you are an undergraduate, so you can't bear that much of cost. That's all about the channels and websites. And finally, the Kaggle I showed you, and Hugging Face. Hugging Face is kind of a community. You can create account, you can find models, data sets, right? These are the models uploaded by different people in the world, right? Data sets are available here. Yeah, that's all about the sources. And finally, it's time for your questions. So thank you very much for your being here, and it's up to you. You can ask any question if you have any need to clarify the things. It's your time. You can ask the question through the chat as well, or you can unmute yourself and ask any question. No questions? It seems no one asking questions. I don't know actually. You got the ideas related to this refill. Of course, it's actually you never heard of most of the terminologies in this domain, so it doesn't matter. So let's start somewhere, right? So as I mentioned in my previous slide, so just start from particular place and push your boundaries little by little, right? So don't worry about it. If you are willing to enter to these fields, there is a huge opportunity for you, right? Okay, if we don't have any questions, I would like to hand over Danidu to continue. Thank you very much.
Thank you very much, Mr. Warunajith, for that incredibly insightful session. You have truly helped us visualize how to bridge the gap between traditional software development and the specialized world of AI and ML. The practical advice on internship preparation and the technical shape required was exactly what we needed. And thank you everyone who joined us tonight. We hope these insights help you confidently step into your future roles in data science. Stay tuned for our upcoming episodes as we continue to explore the frontiers of the technology. I'm Danidaran Sikka signing off as your host. Have a pleasant evening.